with these PowerPoint presentations that come with the book, guys, they're really nice summary of the book that you have, so you can follow up with me with chapter 5. I know a lot of you have already read the chapter. It's really nice information to read. Oh, by the way, chapter 4, I didn't do through the calculation that they did the chapter 4 because if you remember before the holidays, I walked you through how to circuit receptacles on lights. I have a really nice PDF file and presentation about how to circuit lights and receptacles before the holidays. So chapter 5 talk about receptacles and switches. No, so what's the difference between receptacle and switches that we have done in the past and these receptacle and switches? One word: they are more robust. They're used in non-dwelling. They can handle more use and abuse. This is really the most important thing about this this chapter. So if you do me a favor, grab your chapter 5 and you can follow up with me. I'm going to highlight a few things I think it's important for you to do. So one thing, guys, switches and receptacle rating for particular application. Let me tell you one little thing, and I know Chris was looking at it, and you guys counted it with the project. One major difference in terms of switches and receptacles between what we did in the dwelling and the non-dwelling is the layout of the receptacles and the switches. How many receptacles and or switches do I need in a commercial building? Where does it say in the building that you guys have, when you will be laying out your receptacles today, how many receptacles do I need in a cubicle? Where does it say in the code that I need, like in a criteria that we have from Halberg, if you remember, every cubicle on a wall, it's going to need a quad of 4 receptacles or 2 duplex, as well as another quad receptacle, as well as another duplex. So 6 single receptacles or 3 duplex receptacles. Where does it say that in the code? Nowhere. That's where that's why people hire us. Thanks God, because we are the ones who are supposed to come up with a criteria to lay out the receptacles in a commercial and non-dwelling building. What you're looking at Halberg, if I were you and you are not working in the field, I will keep it close to my heart, because if you get into a commercial building similar to this and they ask you, we're going to lay out the receptacle in this building, do you know how to lay it out? Yep, I have an example. It might not be the best, most accurate example, but it's an example. It's always, without sounding preaching, guys, it's always good to go to your supervisor with something in hand than going and saying, how am I going to do it? You do it, you get it based on the criteria that we get all the office. This will cover all offices, office buildings, all cubicles, mechanical equipment, the criteria for laying out. So just want to remind you, the sheet that you have in front of you is very, very important. And it's coming from an engineering firm. That's how they do it. So we talk about switches and receptacles, proper rating and so forth. Install various types of receptacles correctly. Single pole, 3-pole switches, guys, and 4-pole switches. We talked about this in the residential. So what's the difference, Chad, between what we've done in the house and now? Again, more robust. You're going to see that we use them actually in a real good application because of the energy code. Single pole and 3-pole and 4-pole switches, guys, they're not used a whole lot in a commercial because of the energy code. You need to have more auto control of your lighting system than in a dwelling. So you're going to see a lot of the stuff for the switches that we have in our building right now. They're asking about low voltage switches. It looks exactly like a snap switch. If you look at it, when we go to Halberg and you look at these low voltage switches, 24 volt, they look exactly like this switch, except they are being operated with a 24 volt, and they're turning on and off a relay instead of turning on and off a lighting fixture like this. They turn on and off a relay coil, which in turn drive a fixture through a contacts to open and close. Now we're getting into more lighting control system. So that's really the major things when it comes to switches. When it comes to receptacles, you're going to be using a lot of robust receptacles, very expensive receptacles. They call them commercial grade receptacles. Spec receptacles. When you guys do the takeoff for Chad, when we give you the software, you're going to find 2 types of receptacles in the takeoff. One that says spec receptacle. You're talking about $2 or $3 receptacle, and you're going to talk about the other one is residential receptacle, 33 cents. I don't have them with me. You've seen these little skinny, little cheap ones. So that's the difference between a receptacle you do in a commercial building and a receptacle you do in an industrial building. A couple of hints about receptacle. I'm going to be going through, guys. There's NEMA, but you've seen the NEMA standards for receptacles. I'm going to flash in a few seconds here and just highlight the major ones that we'll be using. The difference in plugs and receptacles between ambiguity and voltages, that's also NEMA. I'll flash it and I'll show you a few things really interesting. Hospital grade receptacles. This is having to be a hospital grade receptacle. They have a little green dot by code. You have to identify them with the means. A green dot is commonly used to identify it. So who cares? What's the difference between this one and the one in my basement? This one is more robust. This one's 3 to 4 times more expensive than the one in my basement. Why do we specify it? Because it's more robust, it handles more abuse, and it lives longer. So when you guys go to the commercial industrial, please switch your mind into the cheap residential type receptacle switches that we used to do is no longer approved in any engineered project. Can I use them by code? Yes. Yes, I can. I can use a receptacle switch anywhere here. A residential 33 cents receptacle, anyone here by code, and that's okay. Engineered project, most of engineers, 99% of engineered projects are going to ask for commercial grade receptacles, more robust, or hospital grade receptacles. So we'll talk about these guys in a second. Hospital grade receptacles. The hospital grade receptacles, guys, is again, as I said, more robust. You're going to be very similar to this one, more robust. And then, and most of the time, well, they changed in 2011. A lot of application for hospital grade receptacle require an isolated grounding system. We'll talk about this one in a few seconds here. This is for the manufacturers. The terminals, guys, you've seen terminals for this example. The terminals that you can identify as a hot and ground and grounding terminal. This terminal right here, see the green terminal. I don't know if you can see that end here. The green terminal is always ground, right? So that's identified by NEMA. The silver terminal. My silver terminal is right in here. I don't know if you can see it. This is always the neutral, silver terminal. You don't have to know this as a designer. If you're a project manager, you must. Otherwise, the electrician will make a lot of fun of you when you don't know which side, where am I going to land my hot on this receptacle? You guys are designers. I mean, you don't have to know that to design the system, right? But if you know it, you'll be a much better designer in my book and much better, especially estimator or project manager. Okay, and the other one, guys, the brace color terminal, which is that side here. You can see it. I can pass these. This will be your hot. You could be landing phase A, phase B, or phase C right into this terminal. Looking at it, the one on the right, from looking at it this way, guys, is the hot. The neutral on the left, and the bottom is going to be the ground on this configuration. This is a 20 amp receptacle, plug-in type receptacle. So that's a NEMA configuration. Before we get into the classification, guys, I would like to go right in here because I think these are interesting when we talk about NEMA. And let me just talk about the receptacle that I am holding in my hand. You guys have seen this before. If you haven't seen it, please get used to this one. Way at the top, you have branch circuit. Basically, branch circuit rating, 15 amp all the way to 60 amp. You can get higher than 60 amp specialized, up to 60 amp, right? So if I need, for example, if I need 25 amp receptacle, which one am I going to use? 25 amp. I'm between 20 and 30. I want to go to the 30 amp. So if I have a 20 amp dedicated circuit and I will need feeder receptacle, which receptacle would you put a 25 amp circuit, branch circuit on? Would you put it on a 20 amp or would you put it on a 30 amp? The 30 amp, a little bit more, that's fine. So that's what these categories are. The voltage, the amps, there's a receptacle on the plug. You know what a receptacle is. A receptacle, you're looking at it right here, the plug, the one that you plug it in. And there's 2-pole, 2-wire, non-grounding. Forget about these. The first row, we don't use them anymore, except for replacement. The second row is the one that you use all the time. So I want to remind you, this one I'm looking at right here in the front of you guys. This is a 20 amp, 120. This baby is receptacle right here, right here. So it's NEMA 5-20R. NEMA 5, the number is 5, 20 is for the amp is 20, and R for receptacle. So that's what you're looking at, 20 amp right here. The 20 for the amps, can you guess in the name? The 20 for the amps, the R is for the receptacle, the 5 is the NEMA configuration, number 5. The one next to it, so easy. So if it's NEMA 5-20R, what do you think a plug that goes in NEMA 5-20R is going to be named? Duh, you just get rid of the R and you put what? A P. So a P for the plug, R for the receptacle. Otherwise, guys, it's a nightmare. Otherwise, if we don't have these, nightmare. Remember, 50 states plus a couple of territories, and 3 million people using receptacles, different voltages that we use in the US. If we don't have standards, you can't be buying equipments. Equipments have to follow these standards when you buy it. Any questions, guys, about this? Any questions? So you can have the 5-20R in one 520-R right here, or you can have 2 of them in one yoke, or 3 of them in one yoke, or 4, by the way, 4 of them in one yoke. Any question, guys? So you see the voltage up to 100, this means up to 124.5. Now if I want to go to 250, can you guys see that the voltage is slightly higher than the nominal voltage? The 120 voltage, the receptacle rated slightly higher than the nominal voltage. The nominal voltage is 120. They rate them a little bit higher voltage so they can handle more stress. So 125, 250, that receptacle will be very commonly used on 240 system. Here's your all your 240 system. Two pole is 2 hots, or hot and neutral, 3 wire, the 3rd wire is for the ground. This is most of the time you're going to be in this territory, as you can see. Moving all the way up to 277, if you have receptacle AC 277 and all the configuration for it based on the amps. Look at that. You can buy a 277 50 amp receptacle unplugged with 2 hots, and a ground. With a hot and a ground in this case. Yes, sir.
Where do you use the 2-pole 2-wire receptacles? I know I've seen probably.
These are the non-grounding one, the one that looks like this in your. This is a 2-pole 2-wire.
Okay. So we're looking at.
There is no ground. Can you see they're missing the ground here?
Yeah.
On all of them. Well, you no longer can use these, except for replacing existing systems.
Where's the 347?
347, it's in a 600 volt system. Yeah, not commonly used, but they're 600 volt system, 347. Any question, guys, about these configuration? If you move the 2-pole, now you move it to the 3-phase system, it becomes 3-pole. If this is, by the way, this territory here, right in here, that's for your single phase. Now, very few of us will work on receptacle 3-phase. Most of the time, if we have a 3-phase load, guys, we have a disconnect switch and we hardwire. But you can plug in a 3-phase load. So if you're looking at 3-phase load, suppose, look at that, 3-pole, 4-wire with a ground. Why 4-wire? You have phase A, phase B, phase C, and a neutral and a ground. So if you look at this, let's just say a 20 amp, right? The 20 amp. So 14. This one, let's go to the 480. They don't make them. This is the 250. That will give you a 3-phase, a 208 system. 3-phase 208 system. Here's a 20 amp right here. This 20 amp, guys, is going to give you phase A, phase B, and phase C, and a ground. Phase A, 4-wire grounding. Phase A, phase B, and phase C, and a ground in this case. Can you guys see that? Phase A, B, and C, X, Y, Z, and the ground, the plug that goes with it as well. All the way to 50. I can have a 15, a NEMA 1560P and NEMA 1560R. This is a 60 amp, 3-phase, 208. I can wire it with 208. A 3-phase only, no neutral, but with a ground. Can you guys see the G ground for it?
So we tend to hardwire up because it's probably cheaper than
cheaper, easier. You don't want people to unplug them too. I haven't seen a lot of 3-phase 60 amp loads plugged in.
Yeah, it'd be interesting to see.
Well, where they can do them, here's where they can use them, commonly used, guys, and machines, manufacture, assembly. You have the plug-in coming in, and you can plug, or you can have a disconnect too. So you have a disconnect at the top, and you have a plug coming out of that disconnect, and you plug. You have the plug, and you have the what do you call the receptacle up, and the plug. You plug it in. Most of these are locking type receptacle where you can plug and lock. These are you don't use. This is plug-in. Use the twist, the one that has a twist with them. So this is, you don't have to know all of these guys, but this is a very common application for the receptacles. Let me go to the most
Is the phase wiring critical on these, on the installation?
phase wiring.
So to make sure you have phase A.
Yes,
A and B.
yes, X, Y, Z. Phase A, phase B, phase C. Yep. Otherwise, in a three-phase system, you know what happened in a three-phase system. You, instead of exhausting the air out, you start bringing air in.
Yeah,
You're reversing a motor. Polarity, they call it polarity, is very important. Now, if you guys get into three-phase, you get into the locking type receptacle. Let me tell you the same receptacle that we looked at right here. Two pole, 3 wire with a ground. Right here, 2 pole, 3 wire with a ground, 20 amp. L5-20. The only difference between L5-20 and this one, there's an L in the front of it. This is 5-20R. This is 5-20R. If you make it a locking type receptacle, they put L in the front. And the same thing for the plug, they put L. L for locking type. Everybody knows what locking type? Right here, you're looking at the top. You push it in. All these are locking type receptacles on the walls. You push it and you twist it. It locks. Locking type receptacles. Any questions guys about this? So what's the importance for this for you? Keep this handy. If you get into an application, we know what this is, but if you get into an application and you need a 50 amp locking type receptacle and you need to order it for your project, 50 amp locking type receptacle for 48277. Let's go look at that one. I need a 50 amp receptacle for 480, a 3 pole 480, of course with a ground. Right here's a 3 phase 480, right? 3 pole 4 wire, and I need a 50 amp receptacle. Here you go. A 50 amp receptacle will be NEMA L1650R is the receptacle, and the plug is P, is the plug. Then you order, you write it in your spec, and you order this receptacle for that load. That's where we encounter them. Hubble makes tons of these guys. Locking receptacle. I was involved in ordering stuff bigger than this one for 200. Like if you want to order a 200 amp plug, where would you order a 200 plug receptacle? See if you have a portable generator, and they use them a lot in cities. You have a city, and they have a portable generator on a truck, and there's lift stations. Lift stations, they move the bad stuff that comes from my house and yours and send it all the way to the wastewater treatment plants. If they lose power there, you know what's going to happen if you don't go and pump this sludge and the stuff? Your streets are going to be flooded with sewer system. So they send these portable generators on a truck. They pull in next to, probably you've seen them in lift station, and big, huge plug, the 200 amp 48277 plug. You plug it into the control panel, and you start your generator. And you run these until you empty it, then you move to the different sites. You could be involved in sizing these big Hubble ones. So then you would go to the manufacturer's literature for this. Okay, any question guys about this? I thought just to flash them a little bit. All right, if you have electronic equipment like what we did guys in our project, electronic equipment, there's a lot of interference with electronic equipment, so the Smarter Than Chad decided to have an isolated equipment grounding conductor with them. And you can see guys, if you look at our spec here, calls for an isolated ground receptacle, isolated ground conductor to be installed with every branch circuit to feed these receptacles. Why would they use something like this? It minimizes the interference. What does the interference? You type on your screen Chad, and you type Chad and it shows Chris. You put on your typewriter, you put Chad, and on the screen it shows Chris. Exaggeration here. So that with all these, they have they call it noise. So they specify receptacle outlets for sensitive electronic equipments, and they have isolated ground receptacle. Is it code to have an isolated ground receptacle? No. Where would I use an isolated ground receptacle? Where I have loads that could be electronic loads that could be interfered with I don't like the word tampered, but affected by noises, signals, and so forth. A good example of this, cashiers, guys. The cashiers, they always put them in isolated ground receptacle. When they slide your credit card, they want to make sure you get the right information, no interruption whatsoever. Okay, here's an isolated ground receptacles. I don't know if it will work today. Isolated ground receptacle. You can have first the receptacle have to be designed as an isolated ground receptacle. Isolated ground receptacle. So your receptacle have to be an isolated ground. I don't know if I'm going to pass this one, guys. Basically, the grounding slot here, the bottom, is completely isolated from this metal frame of the receptacle. Isolated ground receptacle. The metal, the ears. Can you guys see these ears here? And the grounding slot is completely isolated. And you can see right here, when you put your grounding conductor, isolated grounding conductor right in here, you're grounding, the only thing that's grounded in this receptacle is the slot. These ears are grounded through the frame of the box. So I can't have an isolated ground receptacles with this one, for example. It defeats the purpose. It completely defeats the purpose, of having an isolated ground receptacle. Because the ears right in here, as well as the grounding slot here, represented by this little button. I don't know if you guys can see it. They're all tied together, metallically tied together. So what do? Then you take a number 12 isolated ground receptacles, or number 14 in this case, all the way back to, you can take it all the way back to the service panel. Normally we don't do that, guys. You take it to the panel. If this panel has an isolated ground system right here, you bring it all the way to this bar, which is completely isolated from the box, and from this bar here, you take another isolated ground conductor all the way to the main, and you land it on the main equivalent grounded conductor bar. So to be aware of that one, in our project, guys, they're asking for an isolated ground, an insulated grounding conductor, insulated grounding conductor. Is this code? No. Why would they use this one? Because of the sensitivity of the load that you plug in here to wave and interference and so forth. So standard conventional and isolated ground receptacle. I don't know if you guys can see this. This one here is tied all together to the frame. This one is completely isolated, going all the way back. So in a box like this, Chris, then you're going to have two grounds. One ground to ground the yoke, the ears. You have to have a equipment grounding conductor for the yoke, the ears. And the other equipment grounding conductor is for the slot here, the grounding slot, which is that little screw here. You have to have two. Most of the time, one will come from an EMP conduit through the box. That's the dirty equipment grounding conductor. And the clean equipment grounding conductor comes from a number 12, a fully insulated green conductor that land right into this slot here.
So you wouldn't really run two green ground.
You can.
Green wires and then ground one to the box.
You can. You can. Commonly, yeah. Yeah. Cleaner. But commonly, what they use is the dirty ground will be through the pipe, and the clean ground will be through the fully insulated green conductor, like you see down here.
You seen that done with Romex? So
Romex, boy, usually we don't even think of Romex when we think of these. How you can't do it with Romex. I don't know if they make an insulated ground conductor with Romex. This is mostly conduits or MCAC cable. MCAC cable, guys. If you can buy an MC, if you're dealing, Nick, if you're dealing with MC cable or AC cable, now inside the MC or the AC cable, you're going to have two grounds, or the shell will be used as a ground. One is fully isolated green conductor for that grounding the slot, and the other one is the shield of the shield of the MC plus some adjective with the AC cable that will be used to ground the box, the metallic box, as well as the ears and the frame of the receptacle. Any question, guys? Most of the hospitals that they specify, most of the application that they specify will have two. Now, in our project, here's your issue. In our project, guys, we're having underground PVC conduits. So this is where you become. If we're underground PVC conduits, what are you going to use? You're going to need two grounds, one clean, one dirty. So in this case, you're going to end up pulling at two isolated grounding receptacles. One will be green, used for the clean, for the receptacle, and the other one will be used to ground the box.
Well, let's just say for argument's sake, you had an office with 4 of these, one on each wall. And you commonly,
Daisy chain them?
yeah, the isolated thing. Is
Yep.
that commonly-
Yeah, you can daisy chain them, take them all the way back to the source. All the way back to the source. Electronic equipment, guys, there's a bunch of things. For sensitive electronic equipment, we use also surge protective devices. I don't know if you remember what Todd was saying. So, number one, guys, you use an isolated ground receptacle. That's just to minimize the interference of signals being, basically the equipment on a conductor or the conduit being used as an antenna, grabbing all these noises, aka they call them noises, aka signals, stray signals, bringing them all the way and dumping them across your cashier, the cashier device that you're using, or your computer. So to minimize this, we use an isolated ground receptacle. Now, there's also surges, voltage surges, spikes, static charges, lightning, electromagnetic interference, radio frequency interference, all this good stuff to minimize it, especially the surges, guys. They have surge protective devices. Surge protective devices, especially electronically devices. Look at this. We talked about this one, guys. Look at the signal. If it sees a pulse that goes all the way to God and comes back, it shunts you to the ground. Take that voltage represented by the current and take it down to the ground. Take it down to the ground. So in a case like this, not only you need an isolated ground receptacle, but in a case in a case for the surge protective devices, which looks, here's your voltage coming in and then goes all the way up, got screwed up and came back, got screwed up down and came back and then went back into normal. That's called the surge. I don't know if you guys can see that. That's a big surge. So what the surge protective device is, come over here and chop this piece here and chop this piece. What does chop means? It literally takes the phase conductor and they use a device that based on the high voltage, if you put high voltage across this device, it becomes conductive and conduct that voltage directly to the ground. Take that voltage component represented by a current and tie it to the ground. Who cares? By doing it this way, guys, they protect your equipment. They protect your equipment. So, grounded neutral conductor, size start the connection. So I know Chris, you and I were talking about methods of equipment grounded conductor. If you go to this 118, it will list EMT as an approved equipment grounded conductor to a limit. It will list a bare conductor. It will list rigid, EMT, even flexible metallic conduit under certain circumstances can be used as an equipment grounded conductor. So these are places where they list them. GFCI in a commercial building, guys. Now we're talking commercial. Review of GFCI in a commercial building. GFCI in a commercial building must be even every receptacle within 6 feet of anything must be GFCI. Within 6 feet of any sink. Commercial sink, with some exceptions in hospitals, have to be GFCI. Outdoor receptacle, GFCI. Indoor wet location receptacle, GFCI. Bathroom receptacle, GFCI. Kitchen receptacles, GFCI. What else have we forgotten? Rooftop receptacles. Any wet location have to be GFCI. So these are places where they added locker rooms in 2011. If you have a locker room, sport facility with locker rooms with a shower area, these receptacles have to be GFCI. So there's a lot of application for GFCI in a non-dwelling. Most of these receptacles are the most convenient amps, Chris, the most convenient amps right here, and the most convenient voltages, which is which one? Right here. Most convenient amps, these two amps, and these this voltage have to be GFCI. By the way, when we deal with a commercial building, forget a 15 amp receptacle. Don't even deal with 15 amp circuits or receptacles. The minimum, a good engineered project, guys, the minimum branch circuit that you can pull and the minimum receptacle that you can put is a 20 amp receptacle, 120, landing on a 20 amp circuit branch circuit. It's really not worth putting a 15 amp receptacle, if you ask me. Any question, guys? Here's a few places: bathroom, kitchen, rooftop units, outdoors, within 6 feet of any sink. In our project, take our project now. In our project, all the receptacles, outdoor receptacle, GFCI. Receptacles, do we have a kitchen? We don't. Well, we have a lunch room. A kitchen is defined. Anybody knows how the kitchen is defined by the code? A kitchen is defined by the code. Any area that have a permanent place of cooking, as an arrange permanent place of cooking, and a sink. We have a sink in our project. Do we have a permanent place of cooking? If you have a microwave, fixed microwave, we do have a microwave. If it's fixed, that will be a permanent place of cooking. It makes it a kitchen. If it's not fixed, then it's not a cooking. It's not a kitchen. Either way, in our project, guys, all the countertop receptacles, if you remember, countertop receptacles we put them GFCI anyway. So these are the only places, and that would be GFCI. In the mechanical room, since it's concrete and all this stuff, it's a good idea for maintenance to put a GFCI receptacle there too. Any damp or wet location, even if it's not listed, it's a standard, industry standard. If it's a damp, wet location, for safety to put a GFCI receptacle. Any question, guys, about the 20 amp, 15, 120 GFCI receptacles?
Yeah, and all of our spec tells us what size of the receptacle.
They don't say like 20 or 15. No, they don't say that one. So all the receptacle that we're installing in this project is 20 amp receptacles. 20 amp receptacles. Typically standard. Though they talk about GFCI, for example, they have receptacles. One receptacle for every 2 sinks in the bathrooms. They say GFCI in it. Exterior mechanical room, GFCI. So they listed a few GFCI locations here, which is directly from the code, wet location and bathrooms. Receptacles, existing buildings. This is just, this will tell us, guys, we rarely get into a commercial building and change it. If it's a commercial building and it doesn't have a ground, if you ask me, go rewire the whole building if it doesn't have a ground. This is mostly for residential. You walk into a house and it's not ground, there is no equivalent grounding conductor. So you are allowed to change the non-grounding receptacle with a grounding type receptacle, GFCI. If you have receptacles in an electric baseboard heater, that's also be considered receptacles. I wouldn't see this used in a commercial building. This is mostly residential probably, but you could have a baseboard heater in one area and you need a receptacle too. 2 birds in 1 stone. You put the baseboard heater, bring a 20 amp circuit to feed the baseboard heater, and another 20 amp circuit to feed that receptacle, which is part of the baseboard heater. So you can't feed the baseboard heater and the receptacle from the same circuit. So that's it in terms of receptacle. I want to remind you guys, receptacles in a commercial building does not have to be tamper resistant. Does not. Receptacles in a commercial building, if it's outdoor in a wet or damp location, have to be weatherproof though. It has to be weatherproof. If it's in a damp or wet location, it has to be weatherproof. Weatherproof means it has to WPU, WR, weather resistant. And if it's outdoor in any location, you have to have an in-use cover. So be aware that all your receptacles outdoor in a commercial building, they have to be weatherproof and they have to be in-use cover. That bubble in-use cover. That's receptacles. Snap switches, you guys deal with snap switches. The toggle switch, you're looking at them right in here. My snap switches. There's AC general use snap switches, or AC/DC. You can use them in AC or DC switches. Most of the time, the ones that we have is AC snap switches. We're not switching DC in this project.
What's the mechanical difference between?
I don't know the way this. Here's what I know. If you are to break a DC circuit, the amount of arc is higher and more severe than an AC circuit. So you need the contacts to be more robust. And what are we doing? What I've done here, I broke an AC circuit, right? I broke an AC circuit. Had this been a DC circuit, when I break it, every time you break it, you're going to have an arc. That arc is much lower than if it was a DC, and for one reason, because the DC has the only impedance that limit the current in the DC is what? Is the R. In an AC circuit, you have the R, and you have the reactance, and the impedance, basically. So it has to be more robust to be able to break it.
So in general, if it works for DC, it would work for AC in the same way. Based on what you're telling me.
Yeah, it's more severe. Yes. I don't know if there's any other characteristics that I don't know about the DC, honestly. Yes, DC is more severe in terms of being interrupted. Switches, I don't have any switches here, but if you have a switches, guys, the switch, when you have a switch like this, and you have a box, the switches, you have to ground the switch itself. In 2002, I think, that we start grounding the switches. Every switch have to be grounded. I want to add to the snap switches, there are two things. The switch have to be grounded, number one. Number two, every switch that switch a light that's coming from a cable must have, based on 2011, neutral. Doesn't matter residential or commercial. If you're using an AC cable or an MC cable, cable, I can't emphasize. If you're using cables, you're wiring with cables, then you bring it to the switch, and then the switch have to have a neutral, AC or MC cable. Metal yoke or snap switch is considered grounded when secured by metal screws. When switches, this is just talks about grounded. When you look at this switch, guys, right here, the switch is landing on a box. If you land a switch with two screws on a box, in the box, and screw it to the box, it's considered grounded. What does that mean? You don't have to have another for a switch. You don't have, even a receptacle, the same thing. If I land this receptacle right in here on with two screws into the box, it's considered grounded. I don't need to pull another conductor from that little slot. I can, if I want to, and ground it to the box, unless I'm talking about isolated ground receptacle. That's a whole different story. If it's non-isolated ground receptacle, by landing the switch on a box, like a box like this one, with two screws attached to it, that will qualify. It's grounded. It's already grounded. And the cover for it, if it's metallic, it's already grounded because it's attached to the metal. Metal to metal through two screws, grounded. That's what they're talking about, guys. You don't have to pull another equipment grounded conductor. The metal face is grounded through the switch. Any questions, guys, about the receptacles or the switches? The receptacles or the switches? The only thing is where to put GFCI receptacles. Do you need an isolated ground receptacle? Yep, only if there's interference with electronic equipment. Okay, moving into conductor color codes. I brought a couple of color coding conductors. When you guys deal with color codes, and you've seen this with me, when you're dealing with color codes, you're dealing with three-phase system. Always, you're dealing with three-phase system. This system is commonly used for 28123. This is what your building is going to look like, with wires like this. Black, red, blue. Black, red, blue, white, and green. This is a three-phase, 220, a three-phase, 20 amp, three-phase circuit. 20 amp, three-phase circuit. This one is capable of feeding. Remember how we did the math up to probably, depending on the size, 17 fixtures you can feed from each one of these. 17 times 3, that will give you how many fixtures you can feed from these 5 wires I'm carrying in my hand. 5 wires. If you have we're not using it this time, but if you are using a 48277 Your neutral is going to be most likely gray, and you're going to use the orange, brown, and what's the other color that we use? We use orange, brown, and yellow. Orange, brown, yellow as your colors for grounding. So the code doesn't say, the only things that cares about the code, if you guys look at, is the grounded conductor. Your grounded conductor can be a gray or a white, other than green, so you can have most of the time you're going to have a gray or a white. Most of the industry standard guys, the gray goes with the 48377, the white goes with the 28120. And oh, by the way, if you have a building that has two systems in the same building, you must distinguish between the branch circuits and the feeders. Color code the branch circuit of system A and the branch circuit of system B and the feeders. You have to. If you don't, if you have only one voltage system, like the building that we use, Chris, only one voltage system for all practical reasons, as long as I use a green as a ground equivalent ground conductor and the white or the gray as a neutral, for all practical reasons, I can use black for phase A, phase B, and phase C, and that's okay with the code. Obviously, we don't do that because we want to identify by phase. So what they do is they color code like this, red, white, blue, with green as your neutral, and the other colors as your phase, plus the green as your equivalent ground conductor. And you have the yellow, brown, orange, plus the gray is your 48277. Any question, guys? One common, very important things. Do I need the phases of two voltage systems to be identified? Yes, by code, the branch circuits and the feeders at every panel have to be identified by phase and by neutral. If you have two voltage systems coming to the building. If you don't have, then the only thing that need to be identified is the equivalent grounded conductor green or bare, and the grounded conductor, aka the neutral, have to be in white or gray. Any comment, guys, about identifying the neutral? Now, this is if we're dealing with conduit. If we're dealing with cables, commonly the same, with some exceptions for cables. So if you're using an MC cable, you're going to use an MC cable. You're going to find almost the same thing. If you have an MC cable for 480, it's going to look exactly the same with a cover over it.
On that yellow, brown, orange, are those considered ABC or as standard convention?
Yellow, brown, orange, yes, ABC. And in that one, black, red, blue. Black, red, blue is phase A, phase B, phase C, absolutely. And the white, of course, the neutral.
And that equates to XYZ.
XYZ, thank you. XYZ on the receptacle, yep, absolutely. When we land them on the receptacle, it'll be XYZ. Phase A, phase B, phase C. If you're dealing with a conductor, this color coding for the grounded conductor, this is one of the most confusing parts is the color coding that I just went through, especially for the grounded conductor and the equivalent grounded conductor, is for conductors number 6 and smaller. If you have a conductor number 6 or small in a cable or in a conduit, they have to be color coded. Green for equivalent grounded conductor, and white or gray for grounded conductor, the neutral. If your conductor is number 4 or larger, now this is for R, number 4 or larger, guess what? I can color code them. Here's what you can do for all practical reasons. I can grab this black conductor, and I can make phase A, phase B, phase C, the neutral, and the equivalent ground conductor. All of them are color coded black. If it's number 4 or larger, and you'll see them in a lot of buildings, I can make all of them black color by this black and use it for phase A, phase B, phase C, neutral, and equivalent ground conductor. Now the only thing you need to do is a few things. For the equivalent ground conductor, you either have to go put a tape around it, green tape around it, or you have to get rid of the insulation, a couple of inches of insulation here. So that when I look at it, oh yeah, it's uninsulated, that's a ground. Most of the time they tape around it. They put a green tape around it. Now it becomes equivalent ground conductor. You have to. If I'm using this one as a grounded conductor, and I'm using 28120, for example, I can go and put a white tape around this conductor at every location where I have access to this conductor, in a J box, inside the panel, where it lands with the equipment. I don't have to cut through the conduit here to tape it. Just where I have access to it. Wherever I have access to it, you can tape it with white. So again, you can use one color code for all the three phases. By the way, the three phases, then do I have to identify phase A, phase B, phase C by code? No. If it's one voltage system. If it's one voltage system, you really don't. But most of the people, guys, just because of a good practice engineering, they will go, this will be a red, this will be black, red. They put a red on phase B and a blue color here on phase C, just to identify.
Well, if you don't, how do you keep the receptacles straight?
How do you keep the receptacle straight? By code, I don't like to defend it. You really have to, almost have to. But by code, if you have voltage system, here's a black conductor, this phase A, phase B, phase C, and figure it out. Basically, the code is satisfied. The only time I need to identify this one, if it's phased by color, if I have another voltage system coming to the building. Now I have a 480, 277, and 28120, then this has to be color coded. Doesn't have to be by color coded by insulation. I have to put a tape in the field, tape it with different colors. A lot of industries, guys, you can buy color-coded cables, very expensive. These are very expensive color-coded cables. That's why contractors buy black and use it for phase A, phase B, phase C, neutral, and ground. And they do exactly what I told you with the tape, they tape around it. But we have a lot of projects where the owner or the engineer specify color-coded conductors for feeders. These are feeders. Now, had these been a number 6 or smaller, you have no choice. They have to be color-coded. Number 6 or smaller. Number 4 or larger, you can use one. I can use blue, as a matter of fact, for everything. Doesn't have to be even black, as long as you identify the neutral and the ground. Any question, guys, about this? This happens when we go do tours. Of course, in the past, the students will walk in and they see a black conductor all over, and it's used as an equipment conductor. I say, Chad, you told us the black has to be used only, or if it's a ground, it has to be green. Well, it has to be color-coded for number 6 or smaller. That's an EC code book. So, any question, guys, about these? This is the color code that we use for 8277 feeders. You don't have to color code them again. You can use a black for any one of them, and color code the black with these colors, just a tape. And for 48277, and the same thing, tape for all these colors. You don't have to be insulated. The insulation has to be colored.
Any type of device that tells you what phase is what?
Yeah, phase. Yeah, you have phase. Yeah, there's a phase. What they call this? Phase identification or for phase rotation. Phase rotation. Yeah. Here's what the utility does. You start with the utility. When they give you 3 conductors and a neutral, right at the service, they identify phase A, phase B, phase C. That's your reference point. From right at the service, you have to identify phase A, phase B, phase C. From there, you take it through your building. You have to follow the same configuration with it. Phase A, phase B, phase C. And the code says is right to left A, B, C, front to back A, B, C, top to bottom A, B, C. And if it's other than this because of old equipment, you have to identify it by color, by writing next to it. We talked about green, guys, or green with the yellow stripes for hot. You cannot use, by the way, can I use the green as a grounded, the green? If I have a conductor, this green conductor, now I want to use this green and identify it as a black and use it as a hot. Can I do that? No, you can't use a green. Can I use a bare conductor as a hot? Yeah, we use them all the time if you put them on a pole. That's kind of the confusing one. If you put them in a pole, that's what we use, right? You put a pole and you can, bare conductors, you can use them at any time. Not commonly used in a commercial building. Utilities use them all the time. If you look at all these transmission lines, thanks God they're bare. Otherwise, they wouldn't be able to carry current. The insulation will melt because it gets hot and so forth. and they don't. Huh? Most of them are aluminum. Surprise. Reason why?
Light.
Thank you. Wait. Imagine putting copper with all these big transmission lines, the structure that you have to, how heavy the structure have to be to carry that heavy, I don't know, 500 kcm conductors that they're pulling on these transmission lines. Okay, mandatory. Talked about this one. There's a gray insulation. Believe it or not, we have a building here at Dunwoody, guys. The word building. We have the gray. I don't have a gray conductor here. The gray conductor, we see it. The gray conductor in the 70s, if I remember, was allowed to be used as an ungrounded conductor. So you're going to be very careful if you're a project manager. Again, you're not an electrician, guys, so you don't carry tools. But just because a gray in an old building, you walk in an old building, you see a gray conductor, don't always assume in an old building that it is a grounded conductor. It has been in the past used as an ungrounded conductor. We talked about identifying the neutral for a two-phase system, guys. Furnished with the cables. MC, 99% of the time you're MC or AC cable for non-dwelling units, guys. And these come with a very similar color coding inside the cables. Very similar color coding. You can have any other color. You can have pink. Can I use pink as a ungrounded conductor? Yeah, as long as it's not green or not gray or not white, you can use it. Use conduit or cables. Black, we talked about the color return. If you're using, this is right here. If you're using, guys, a cable, only cable, not conduit. If you're wiring with cables, can I wire with cable in a MC cable in a building like this and bring the power to the switch and out of the switch? Yeah. If you're using wiring cables, you can identify, and you're using the switch as a cable bringing power to the switch and out of the switch, then the one that brings power to the switch have to be always the re-identified white conductor. We did this in the residential, guys. You remember the re-identified grounding conductor? So as you know, if it's in a conduit, as you can see, if it's conduits, you have to be color coded. If it's a cable, then you can re-identify the neutral. I want to bring to your attention, if you're wiring with cables, what do you need to do now? You have to bring a neutral. If you're wiring with cables, you have to bring a neutral. So you might have to kiss goodbye, re-identifying the neutral as a hot, bringing hot to the system. Because the reason why here they didn't use the neutral, because by code only 2011 started. You have to bring, if you're wiring with cables, with some exceptions though, you have to bring a neutral. So really re-identifying the neutral becomes not a big deal. Snap switches, guys, as you know, come single pole, everywhere was single pole. You're looking at it, 3-pole, 3-way, or a 4-way, or double. Double means you can turn on and off 2 hots. Occupancy sensors. This is where you're going to wake up, guys. Next week, we're going to bring an occupancy sensor speaker. Occupancy sensors is nothing but a relay. It sends motion in the room. It triggers, send the signal, and disconnect through the relay, disconnect the power circuit that's going to a lighting fixture. So we'll talk about this one a lot, guys, with next week when we go and talk about lighting too. Switches, raised covers, and so forth. This is just about the grounding metal. This is just telling you guys about the size of the screw that you need to put these screws to make sure that the receptacle is grounded, and you do not need to pigtail the receptacle or the switch to the box. You know, so metal faceplates are effectively grounded through this number of screws that fasten them to grounded yoke of a receptacle or a switch. Grounded yoke of a receptacle and switch. The box in metallic yoke must be grounded. Of course, the box we ground it through the conduit or the cable. If you have we talked about if you have a receptacle or a switch in a wet location, it has to be an enclosure, in use enclosure for a receptacle or a switch, special receptacles in use enclosure. Damp or dry location. A couple of definitions because of damp and dry, guys. They define what a damp location, what dry location. Location not normally subject to dampness. For example, this area is damp, is a dry location. Would it be wet under certain circumstances? Yeah, when we're washing it, could be wet, but normally it's not wet. Damp location, protected from the weather and not subject to saturation. Wet location, saturation of water. Wet location, my favorite is wet location. Look at the installation underground or in concrete slabs or masonry is direct contact with underground in location subject to saturation with water. That's where you wash your car, or in other liquids such as vehicle washing areas, and in unprotected location exposed to the weather. These are very clear where the wet location is. Exposed to the weather, wet location, saturation of water, car washing place, or in direct contact with Mother Earth through concrete or non-concrete. That's a wet location. So why it's important wet location? You have to have GFCI and in-use cover and weatherproof. GFCI, in-use cover and weatherproof. So that's what I have, guys, for you. I know I'm going to give you a quick break in a second here, but give me 1 second, one second here. Just to go over, okay, here. Oops. Why did I close it, Chad? Just want to show one little thing here, and then I'll let you go. 5. Okay, this is just identification of the switches that we talked about, guys. Different type. Look at this one. You have to memorize it as a project manager because you walk around. If you ask the inspector for a 20 amp receptacle and they put this receptacle for you, that's clearly a 15 amp receptacle. So remember this, guys. This is the most common, convenient commercial receptacle that you're going to install. 20 amp, 120 receptacle with that little slide to it. Obviously, the one before it was the 15 amp. Okay.
The point of the slide is that you can take a device that has a 20 amp plug on it.
Yes. Yes.
To a 20 amp,
absolutely.
Blow it because it's too hot. You're only supposed to do 80%.
Well, the idea is, yeah, if you have a device rated for 20 amp, you can't plug it in a 15 amp receptacle. Otherwise, you're going to exceed.
I'm saying you can plug it into a 20 amp receptacle that's on a 20 amp breaker. Consume 20 amps, you're over your 80%.
Yeah. It's 20 amp and 15 amp kind of weirdos because they allow you to plug a 15 amp load in a 20 amp receptacle, but not the other way around. They don't allow you to plug a 20 amp load in a 15 amp receptacle. Let's look at the slot, allows you, if I have a 15 amp load, can I plug it in a 20 amp receptacle? Yeah, bring it on. The other way is not true. A 20 amp load, can I plug it into 15 amp receptacle? No.
I mean, if I have a 20 amp microwave, let's say it's industrial
Yep.
quality.
You can't plug it into 15 amp.
No, I know I can't. But
Yeah.
if I plug it into a 20 amp receptacle, haven't I just broken the rules?
If the manufacturer have rated the equipment as a 20 amp and with a plug 20 amp, then no problem, you can plug it in 20 amp.
But I'm overloading the circuit.
And only if it's a 20 amp, most of it, only if it's 20 amp continuous. When it says a 20 amp, means and have a plug on it, this means you can plug it into any 20 amp. So don't worry about that. That's what but I would give it a dedicated circuit though. You're telling me what that's 16 amps, Chad. If it's a 16 amps, most likely if they put a 20 amp receptacle on it, a plug, it is in reality a 16 amps, but they want you to plug it with a 20 amps. They take into consideration the continuous load. That's how it. No, definitely not. In-use cover, guys, this is what you will be looking at if you have a receptacle outdoor in-use cover. A couple of wiring. I encourage you guys to do. I saw you, Chris, you were doing some of these wiring. I really encourage you guys to do. Yes, sir.
Are those, deck and the one side of those covers recommended or required?
They're required. In a wet location, a use cover is required by code. No, not recommendation. Is required by code. So please do me a favor, guys, and get into some of these wiring. Talk about that one. We talked about this one. This is a really nice picture, guys, of isolated ground receptacle. Look how they did. You came from the receptacle through a sub panel all the way to the main service. Most of the time they don't do it this way. What they do, if you have this situation, is they have an isolated ground system in this area, another isolated, and they land it here, and then they go from here to the second panel. So they have two grounds, one dirty ground and one clean ground in that panel. So you land the dirty ground on the dirty ground and the green ground on the green ground, the non-dirty on the non-dirty. Otherwise, you're going to end up pulling a lot of receptacles down to the service. A few things, guys, about I thought this is a really nice single-phase and three-phase circuit. The book talks about harmonics. If you are wiring receptacles that feed electronic equipment, be very aware of the harmonics. Very aware of the harmonics. So long story short, you're going to see in a couple of places where they can. Now this is the phase A, phase B, and phase C.
You've got to explain what they are, so it's really hard to work something in
the harmonics. Yeah. What they do is, if you have electronic equipment, they digest, the way they digest electricity is different than any non-harmonic. So long story short here, actually this is a really nice. When you put a signal, and I know this is for the pulses, but when you put a signal, a 120 signal across an electronic device, guys, the way they consume electricity distort the signal. They distort the signal. So if you can see this one here, instead of being a very nice sinusoidal wave as it's supposed to be, and again, this is a pulse really, it distorted. So if you have a signal, here's a 20 amp signal, you got 20 amp signal like this, and you put this signal coming from Excel across your electronic devices. This is when everything is done and they're working, this is how your signal is going to look like, something similar to this. The question is, who cares? Who cares that my electronic equipment make my signal from this way to this way? They're not linear. The current doesn't match the voltage linearly. This is a bad signal because it adds the neutral, it overloads the neutral. When you take, especially in the three-phase system. The one underneath it, guys, is a pulse. This is why I think I drew some of these. We protect from a pulse here. So if we have a pulse, meaning you switch a transmission line from one side to another, it will send a very high voltage for a very short amount of time. Who cares about very high voltage for a short amount of time? It burns equipment. So they have the TVSSs or surge protected devices that looks at this short amount of time, connect you to the ground, and protect your equipment from that. Protect your equipment from it. Let me see. Here's what we're suggesting, guys. Really, I thought this is really nice. This is just a neutral. If you have a heavy harmonic loads, here's what we solve the problem. I'm gonna let you know. Lighting fixture like above your head. These are electronic ballast. So they have harmonics. They are sloppy eaters of electricity, and they distort the signal, which means the neutral will be overloaded. The third harmonic will overload the neutral. So what they suggest, one example, is to take a neutral with every hot. That's one solution, a neutral with every hot. Another solution, guys, if I can fit 17 fixtures on one circuit, 17 fixtures on one circuit, I can put 15, reduce the load. A third solution, I will get into the solution, is to make the conductor, here's number 14. If I have a conductor here, number 4, each one of these, number 12, I can make the hot number 10. The neutral will be number 10, and all the hots number 12, 10 for the neutral, to accommodate for the high current that's going to be seen by the harmonic. The same thing for the receptacle. Same thing for the receptacles. I think in our project, guys, what we're asking for right here, they are asking in certain application for this, where you can pull a neutral with every 20 amp circuit, because of the harmonic. Grounding, GFCI, we talked about GFCI. Here's where the systems, we drew some of these guys. This is where neutral conductor is to be. This is not a neutral conductor. So we'll talk about this in industrial. A neutral conductor, this is not a neutral conductor. A neutral conductor is when you have two voltages between two hots and a common conductor. Between two hots and a common conductor. So, talk about the identification, three-way switches, four-way switches. Okay, that's all we have. Any question, guys? Any question? Please do the wiring diagrams in the book. I can help you with it too. So.